To pave or not to pave, making informed decisions on when to upgrade a gravel road. This presentation was developed by the Minnesota Local Road Research Board in an effort to inform the public about the many factors to consider when developing a plan to maintain or upgrade a gravel road. How do engineers and public works staff decide when to pave and when to leave a gravel surface as is? Two reports that have been recently published offer some help. Both offer objective methodologies for considering all of the factors in upgrading a gravel road. The first is titled Cost Comparison of Treatments Used to Maintain and Upgrade Aggregate Roads. This report was funded by the Minnesota Local Road Research Board. As part of this project, researchers examined roadway surface construction and maintenance costs to determine possible threshold values to go from gravel to paved. The second is titled Local Road Surfacing Criteria, and it was funded by the South Dakota DOT. In this project, researchers developed a tool to compare the costs associated with different types of roads to determine the most economical surface type. These two projects had different objectives, but both of them offer a method of cost analysis based on spending history for low-volume roads, a method for estimating maintenance and construction costs, and an economic analysis procedure including present worth evaluation. The present worth of a project describes the amount of money needed in today's dollars to fund the roadway construction and maintenance costs over its lifetime. Two key questions must be answered when developing a gravel road maintenance plan. First, what is the best way to maintain a gravel road? And second, when should the roadway be upgraded to a paved surface? These are not easy questions as many factors affect the answers. Why is this an issue? Of the estimated 4 million miles of roads in the U.S., 1.5 million are unpaved. That's nearly half. Unpaved roads serve a valued purpose in our roadway system, but maintenance costs are significant. Paved roadways also are costly to maintain, and both costs need to be optimized. And like everything else, maintenance costs for both paved and unpaved roads are rising. We need to optimize those costs to best serve the public. Reduced funding and resources require us to be more efficient spenders of the money we do have, and efficiently preparing for future maintenance and upgrades allows us to better manage funds that are available now. Other issues that complicate this decision are listed here. Increased development in the urban fringe results in much higher traffic levels and earlier failure of unpaved roads. Changing rural lifestyles and a changing rural population has different expectations than in years past, and agribusiness has changed. Increasingly, family farms have been replaced by corporate farms who use larger trucks to haul bigger loads. These changing needs and their operations have increased traffic and loadings on our rural roadways. Our rural environment looks much different now than it did 20 years ago, so the roads we provide to meet those needs are different too. So how do we know when it's time to pave a gravel road? On the surface, it may seem like a no-brainer, but making that decision is not that easy. Some reasons to pave a gravel road are listed here. First, there are some savings in routine and ongoing maintenance costs. It costs more to maintain a gravel road than a paved road. Second, there may be an increased quality of life that results from more paved roads. Paved surfaces generate less dust, resulting in a cleaner environment and adjacent land. Paved roads result in lower vehicle operating expenses for users and offer increased safety and skid resistance. Also, paving a gravel road can result in positive economic development. Studies show that people want to live, work, and drive on paved roads, so economic activity will follow them. And lastly, political issues and individuals may drive the need for paved roads in an area. There are as many reasons not to pave. Those reasons include a lack of funding for initial construction costs. Obviously, paving a roadway costs more than leaving it as a gravel surface. The current or projected traffic levels may not warrant paving it. And just as paving a road will encourage growth in an area, not paving may control growth in that area. That may be a desired outcome for residents who may like living in an undeveloped area. Also, people drive slower on gravel roads, so keeping them unpaved can be used to control speed. And just as political issues and individuals can encourage the paving of a road, they can also discourage its paving. There are some risks. If we decide to pave, we'll have to fund the eventual rehabilitation and continued maintenance of the paved surface. Heavy traffic may overload the pavement if it's not adequately designed, leading to even higher maintenance costs. Paving the road may require a full alignment or profile upgrade, which is also expensive. A nicely paved surface could lead to an increase in vehicle speeds and attract more traffic. And as noted earlier, some people just prefer to live on a gravel road. In the early days, we had fewer tools to help us decide when to upgrade a roadway, and we may have had to put up with inadequate roads for too long. Of course, back then, upgrading may have meant laying planks or cobblestones. Now we have more options and more information to help us make that decision. As noted earlier, 2 recent reports can be used to help decide when to upgrade a gravel road. The first project was conducted in Minnesota and funded by the local road research board. This project offered an analysis of county maintenance costs, practices, and traffic volumes for individual roads to help determine when it may be advantageous to upgrade that road. This decision is based on cumulative maintenance costs. The initial data collection included 16 Minnesota counties, broken into 4 regions around the state. The researchers evaluated historical costs for maintaining a county road. They also interviewed Highway Department staff and collected data from the 16 counties. The data included maintenance costs for both bituminous, or asphalt, and gravel roads, as well as the volume of traffic traveling over the roads. To get baseline data, the researchers obtained information from annual reports submitted to the State Aid Division of MnDOT from 1997 to 2001. Roads were grouped by funding source as shown here: county state aid highways, county roads which are funded entirely by county funds, and township and municipal roads. Detailed maintenance costs for each road were summarized and split into 5 main categories, as shown on the next slide. And county traffic maps were used to obtain daily traffic counts for each road segment. 4 of the counties were then analyzed further. The typical maintenance activities for those counties are shown here and include routine maintenance, such as smoothing, minor surface repair, and snow and ice removal; repairs and replacement, such as reshaping and resurfacing; betterments, such as placement of new culverts for drainage; special work, such as dust treatments and frost boil repair; and other special agreements for ongoing maintenance activities. The project objective was to develop typical cost per mile for a variety of surface options, including gravel and paved. An initial data analysis was conducted for Waseca County, which provided a snapshot of the kind of information available for use in this study. The researchers assumed that maintenance costs would increase with an increase in traffic. The roads they evaluated were chosen based on surface types and high and low volume traffic counts. This graph shows actual maintenance costs per mile in Waseca County for 5 different roadway surfaces: low volume bituminous or asphalt roads, low volume gravel roads, concrete pavement, high volume bituminous roads, and high volume gravel roads. As you can see, the maintenance cost per mile for high volume gravel roads is highest. This table shows typical maintenance costs per mile for the 4 counties analyzed in the report. The left column shows those counties. The total cost per mile of activities influenced by surface type includes only those maintenance activities specific to the gravel or bituminous surface. Note that the cost per mile for the gravel surface are higher for 3 of the 4 counties. This graph shows average cost per mile for gravel road maintenance for 1 county. Note that regraveling accounts for 43% of the maintenance activities, and smoothing the surface accounts for another 17%. This graph shows average cost per mile for bituminous road maintenance for the same county. Note here that regraveling consumes 15% of the annual costs, and snow and ice control takes 21%. This slide illustrates the effect of traffic on maintenance cost per mile. The roads are grouped by traffic volumes and surface type along the bottom of the graph. an increase in traffic does lead to an increase in maintenance costs, especially for gravel roads. This is due to more lost gravel due to wear and an increased need for blading and smoothing of the roadway surface. Note that at a traffic volume of 200 ADT, gravel road maintenance costs increase significantly. ADT stands for average daily traffic, or the number of vehicles that pass over a given section of roadway in one day. This offers us a possible threshold for deciding when an agency might decide to pave a gravel road. How can this information be used to compare the costs of paving versus not paving for an agency? The report tells us to first review the historical costs of maintaining paved roads for our agency, and if that cost is not available, we can look at one of the 4 counties analyzed in the report to get an idea of what our costs might be. Second, compute estimated costs of maintaining gravel roads per mile for our agency. Third, develop a cost estimate in the same way a contractor would for any new construction project we are considering, and evaluate this to compare the alternatives and make a decision for each roadway segment under question. This graph illustrates cumulative costs for a gravel road over time. The initial construction cost is shown in the lower left-hand corner. After that, there are routine maintenance costs each year. This could include regrading or blading. If no upgrade on the gravel surface is conducted, the yearly maintenance continues, sometimes increasing, depending on the road condition. This annual maintenance is indicated on the graph as periodic regraveling. Or, after several years of routine maintenance, the road may be rehabilitated, indicated by the steep increase in cumulative costs shown here as rehabilitation alternative. This could include paving. If that's the case, annual maintenance costs are less each year after the rehabilitation alternative is completed. Another way to analyze costs is to evaluate the present worth of a roadway for different surface and maintenance approaches. With net present value, the reviewer calculates how much money is needed in today's dollars to fund the roadway construction and maintenance. This slide shows an example present worth analysis for one gravel roadway with present worth inputs. On the left hand of the chart, we see costs and benefits. For this example, there are no benefits or savings during the first 10 years of the roadway lifetime, other than the presence of the road providing access to an area. After the road is paved, there is a cost savings equal to the maintenance costs for the gravel road indicated as a benefit, amounting to $5,175 per year. This savings is offset by the cost of maintaining the paved road, shown here as $1,600 per year. The net difference is the realized maintenance savings. So, with the first approach, our agency can look at typical maintenance and construction costs for this area. We can identify the annual maintenance costs for a given type of roadway, whether it's paved or unpaved, as well as the typical construction costs for a variety of surface projects. We can then perform a present worth analysis to assess maintenance and construction costs for a roadway section to see what the equivalent maintenance and construction costs are in today's dollars. The second tool we have available to us came from the project that was funded by the South Dakota DOT. This project investigated a variety of surfacing criteria for low-volume roads. The main objective was to create a process comparing maintenance requirements for different surface types to assist in selecting the most economical surface type under a given set of conditions. The different surface types include hot mix asphalt, blotter, gravel, and stabilized gravel roads. A blotter road is a gravel road that's been lightly sealed with an asphalt emulsion. Many of the elements of this project are similar to the Minnesota project, but the South Dakota project developed a very easy-to-use computerized tool that allows an agency to input local costs and treatments to fit their own conditions. This computerized tool leads the user through a series of steps to first input information about the road section, including the project limits and the average daily traffic, or ADT, count. Second, input the actual agency maintenance and construction costs broken down by surface type. Then, user costs are quantified. These are costs to the people that actually drive on the roads and include vehicle operating and crash costs associated with the roadway surface type. These user costs can even be weighted to give them more or less importance in the analysis. Then, the computer goes to work. Total costs for building and maintaining each roadway type are summarized after all the initial input variables are submitted. The evaluator then inputs other non-economic factors that relate to all surface types, including growth rates for an area, housing concentration and dust control needs, mail route locations, truck traffic, and political considerations. Again, the evaluator is allowed to weight each of the factors in the analysis. So, how can this tool tell us about our roadways and the relative costs of each decision? With it, we can input actual costs for maintenance and construction activities in this area. We can supplement that with road user costs, such as crash data and quality of life considerations, if we choose, as well as other non-economic factors. The computer program then gives us actual ratings based on the different input variables. We can then select one surfacing alternative over another based on these ratings and on our priority concerns. In summary, paved roads provide improvement over gravel roads in ways that are hard to quantify with dollars. These include improved winter surfaces, improved safety from improved signage and delineation, a safer surface with higher skid resistance, a smoother surface that increases user satisfaction and reduces vehicle maintenance costs, redistribution of traffic away from gravel roads, and an increased tax base on adjacent property. Both studies note that costs vary considerably from one agency to another and from one season to another. The Minnesota study found that gravel road maintenance costs per mile appeared to increase considerably after an ADT level of 200 vehicles per day. On the other hand, the South Dakota study found that paved roads are most cost-effective at ADT levels above 150 vehicles per day. So, we can make some decisions based on traffic data, local construction and maintenance costs, and area growth values to determine when and if a roadway should be paved. Whatever we decide, our agency should begin to record maintenance and construction costs for future decisions and use of these tools, and for comparison to historical data. Both of these tools outlined in this presentation can be used to make informed decisions about paving a gravel road or maintaining it as a gravel surface. Thanks to the finding of both projects, we are better prepared to move forward in developing an efficient and appropriate maintenance and construction strategy for our agency.